In our final lesson for our first lecture, we're going to go ahead and talk about order of operation rules. Now, this is section 1.2, but it's probably one of the more advanced topics in this because it's just a lot of arithmetic. Some people might find that fractions are more difficult, and that's understandable. But typically, the order of operation rules are another set of rules that you're going to see crop up a lot. Just like fractions, when you see them happen, you're going to have to know what to do and how to apply your rules, no matter what the situation is. But before we can get into the order of operation rules, one thing that we have to recap are some basic exponent rules because this is something that will come up from time to time. So exponents are just another way to write repetitive multiplication. So let's take a look at something like 3 to the second power. Okay. When you have an exponent, what you have to remember is that this is basically telling us to take 3 and multiply it by itself 2 times. Okay, and so what we have here is 3 is considered what is known as a base number. And the exponent, or sometimes called the power, is going to tell us how often we actually need to apply this operation. So what we do is we take our base value, which is 3, and we multiply it by itself a total of 2 times. So one thing to note, this is not 3 times 2. It's 3 times itself twice. So that gives you 9. Okay. And again, this applies to all sorts of problems. So if you have something like 5 raised to the third power, that's the same thing as taking 5 and multiplying it by itself 3 times. So as you can imagine, these numbers can get quite large, but we're not going to deal with exponents in a lot of detail yet. So for the most part, you're going to see it limited to smaller powers and smaller numbers. But in this case, 5 times 5 is 25, times one more 5 gives us 125. Okay, so keep that in mind. Exponents are a way to do repetitive multiplication, okay, something that you repeat several times. Another thing to watch out for is your sign rules. And of course, negative signs come back again, and they can be an issue. But something that I want to point out is that exponents also only ever affect the thing they're directly next to and nothing else. And that's key because it changes the way you solve these problems. So in this case, notice that the square power, the 2 power, is on the 3. It only applies to the 3. We actually ignore this negative sign. So what you do is 3 times 3, and that would give you a 9. Now that negative is still hanging out, so this is going to be a negative 9. Here, however, the negative 3 is in parentheses, and the power is on the outside. Now this is important. Normally, an exponent would only ever affect whatever it's directly next to, but when it's on parentheses, it applies to everything. And so that's important because this is not just 3 times 3, it's negative 3 times negative 3 because of the parentheses. And that's important because you'll notice that does change our answer. That gives us a positive 9. So you have to be careful with exponents that when you actually multiply through, that you count out how many negative signs. And we can go one further here. And we can say, well, what happens if we have still a negative 3, but we raise it to a third power? Does that also become positive, even if it's a different number? Well, in this case, no. Because, again, remember, it's negative 3 times itself 3 times. And this, you'll notice, changes things. So this is going to be a combination of a few of the rules we've already learned tonight. So negative 3 times negative 3, that's a positive 9, times a negative 3 gives you a negative 27. So you have to watch out when you have negative signs. For one, they have to be inside parentheses to be affected at all. So if it's on the outside, it sticks around no matter what this power is. Number two, if there is parentheses, you have to be careful and look at how does it play out. Now, a little short tip here that you can remember is when they're in parentheses, even powers will always give you positive values because there's always going to be a pair of signs to cancel out. The odd powers are always going to keep it negative because there's always an odd man out. And that's how I remember it. Odd number, odd man out. But if you're ever in doubt, you can expand these out. Okay. Just remember that you do not use the sign multiple times unless it's in parentheses with the exponent. So in this case here, what we see is a typical order of operations problem. Now, there is a proper way to solve these, and I'll give you a quick hint. You can't just go from left to right. Okay. In fact, that's a common mistake. A lot of people go from left to right and they do 40 minus 24, and then they divide by 8, and then they add by whatever this is. But that's already wrong. Okay. In fact, the very first step that happened there would have been incorrect. So the question is, what is the proper way to do this? Now, some of you might remember that there is a simple mnemonic, a little phrase that's helpful to remember. And so some of you remember the phrase PEMDAS. So let's go ahead and walk through what that stands for and how it affects the way we solve this problem. The first rule is parentheses. What that means is that if there's anything that's inside parentheses, you have to do as much as you can inside before you do anything else. So in this case, we do have a set of parentheses. So the very first thing that we have to do is actually do this 5 minus 3. So we're going to go ahead and do that. And only that. And that's key here. You don't want to skip any steps. You have to do it in order. So notice the 40, the minus 24, the division, all that stays the same. The only thing that's going to happen is we're going to go ahead and do 5 minus 3, which gives us 2. And it's going to be to the second power. The next step in the process is we move on to exponents. So PEMDAS, P, E, exponents. Again, you have to do anything with exponents first. So once you're done with parentheses, notice that the only thing that we have here that does not, or that does have exponents is this guy here. So that means the rest of the problem is just going to drop down below. And once we do that, we're going to go ahead and do this. 2 squared is 2 times itself twice. So 2 times 2, that's going to give us 4. The next 2 steps are to multiply and then divide. Now, you might have noticed that I put these both up at the same time. I even color-coded them the same. And we're going to get into that in a future example here. But for now, it doesn't actually change this problem a whole lot because the only thing we have here is division. There is no multiplication. So we're going to go ahead and do this. So something that's very important to note is that sometimes people are confused. Is this a minus 24 or is it a negative 24? Now, the short answer is those are the same thing. But that doesn't help you when you're trying to do order of operations. So here's the rule. Whenever you are going through order of operations, when you are multiplying and dividing, you treat any positive or negatives as just signs that are attached to that number. So because we're in the multiplying and dividing step, this is a negative 24. In fact, we're going to ignore the fact there's a 40 over here. This is a negative 24 divided by 8. And so what that does then is we know that 24 divided by 8 is 3. A negative divided by a positive stays negative. And what you'll see is that everything else will stay the same and drop down. So it's important to realize that the sign is always attached to the number that it's next to. So this is a negative 24, and that's important to get the right value here, because if you put a plus 3, it's not going to end up to be the right thing. Okay, so we're finally at the easiest steps, and that's the add and subtract step. Now, I'm going to let you in on a little secret here. Adding and subtracting actually happen at the same time. It doesn't actually matter if you do subtracting second or first in this case. The only reason why they put order of operations in this order is that PEMDAS is just easier to say. That's literally the only reason. So you can do them from left to right order if you prefer. That's what most people do, so that's what I'm going to do. So 40 minus 3 is 37, and then we can go ahead and add our 4, and that gives us our final answer, which is 41. So to recap, order of operations, you can remember by PEMDAS, or some people remember please excuse my dear Aunt Sally. And you must go in this order, but there are a few exceptions. Like I said, adding and subtracting actually can happen at the same time. Their order does not matter as long as they're at the very end of your process. So write this down, have this somewhere in your notes, because this is the set of rules that we're going to be following for the remainder of the course. You must follow these rules. There is one final modification to this, and that's when it comes to multiplying and dividing. It turns out that they also happen at the same time, but not exactly the same way as adding and subtracting do. And so it turns out that when you multiply or divide, they happen at the same time, but it must be in left to right order. And so the reason for this is because multiplying and dividing are kind of opposites of each other. So, like adding and subtracting, when they're opposites, then they kind of just happen at the same time. But unlike adding and subtracting, when you add or subtract two numbers, you always get the same result no matter what the order is. So, for example, 5 minus 7 and negative 7 plus 5, well, those both give you the same answer every time. However, if you're multiplying, you always get the same answer no matter the order. So 3 times 4 and 4 times 3 give you 12. But division does not give you the same answer, right? 8 divided by 2 and 2 divided by 8 are completely different answers. So when you get a tie, you have to go from left to right. So a good example of this would be the next problem, and this is kind of a hidden rule. The book does not actually talk about this, but it really should. Multiplying and dividing have to be the same time, left to right order. So to illustrate this rule, what we have here is the problem 12 divided by 3 times 4. Now, if you follow order of operations the way the book does, again, this is a major error I believe the authors made, you would think that the right thing to do would be to multiply first and then divide. Okay, so if we go that route, what we end up getting is 3 times 4 would give us 12. And we're going to go into 12 with that. And of course, you would think, okay, well, in this case, my answer must be 1. But that would actually be incorrect. The proper way to do it is divide and multiply from left to right. So this actually happens first, the 12 divided by 3. And so, of course, if we do that, we end up with 4. And then we end up multiplying by 4 in the other case. And you'll notice here that this makes a huge difference in our answer. One of them is 1 and the other is 16. So very, very important thing to note when you are multiplying, dividing. Yes, they can happen at the same time, but you have to go from left to right order. So when in doubt, if you're not sure when to do a rule and you feel like they happen at the same time, left to right is the way to handle it. It doesn't hurt for adding, subtracting, but it's mandatory if you're multiplying or dividing. So in the next problem here, we're going to talk about a few complications that can happen in these order of operations problems. The first is when you have parentheses and parentheses, or you have brackets and parentheses. Now, the first thing I want to point out here is that in this case, brackets are just another type of parentheses. The only reason why we change it up a bit here is so that way it stands out a little bit better from parentheses. Because as you can imagine, if you have a bunch of parentheses, it might be hard to see where one starts and the other one begins. So keep that in mind, is that brackets basically are part of the parentheses step. So when we go through this, that means the proper thing to do is to go inside the brackets first. But you'll notice that inside we have another set of parentheses. So according to order of operation rules, when you go inside parentheses, you still got to deal with any parentheses first. So we're actually going to start here with the 10 divided by 2. Whenever you do something like that in parentheses, always leave the parentheses there just in case something else were to matter. In this particular problem, it doesn't, but if this was a negative, for example, we want to know that there would be a negative here. So the rest of the problem just drops down as is. So once we drop it down, we still have a set of brackets that we need to deal with. So we're still in the parentheses step. So we have to do this 3 plus 5. Now, very, very important here. We are not in the adding and subtracting step. So even though we are going to add and subtract, we're still in the parentheses step. Why that matters is right here, notice, we have a negative 11 plus 4. Your brain is really good at finding patterns that don't actually exist. So you are going to add these, but you cannot add these yet because we're still in the parentheses step. Okay, very important. These do not add. So in this case, to clear our brackets out, we need to do 3 plus a 5. That's going to give us an 8. Leave the brackets just in case. And then the rest of our problem just drops down. So we're finally done with the parentheses and bracket step. So now we move on to exponents, but there's no exponents here. So we keep on going. We look at any multiplication and division. So this brings up this part here. Whenever you see a number next to parentheses or brackets, and there's no sign in between, so notice there's no plus or minus here, this always means multiplication. So this actually means 4 times 8. And this is why you leave your brackets here, because if you drop them here, you might think it's 48, but it's 4 times 8. So because we're multiplying, dividing, we're going to go ahead and do that. 4 times 8 gives us 32. Again, you cannot add the negative 4 with, or the negative 11 with the 4. That would lead to a major issue. 4 times 8 happens first, and then we go ahead, bring down our last value here. So now we're combining these. Remember the rule for adding and subtracting is when they're opposite signs, you subtract. So this is like 32 minus 11. And you keep the sign of the larger number, which is 32, so it's positive. And that's our final answer here. So be very careful because it's very easy to mix these up. You cannot add these guys. Your brain's going to scream and say -7 because that's really easy. But that's actually one of the last things we do is we take care of that -11. So parentheses, exponents, multiply, divide, add, subtract. Always in that order. So this is a similar problem I want you to try. So again, pause the video and I will resume in another 10 seconds. Okay, so again, parentheses first. We go inside the brackets, we have another set of parentheses. So we have to do this set of parentheses. 1 plus 2 is 3. Everything else drops down exactly where it was before. So we're done with this set of parentheses. We'll go ahead and move out. And we see what we do in here. Now notice we're still in brackets, but we still got to follow the normal order of rules when we can. So you don't take this 23 minus 4, because remember, when a number is next to parentheses, that actually means multiply. So this is actually -4 times 3, which gives us a -12. drop everything down. So we're finally at the point where there's only one more thing to do inside the set of brackets. So we go ahead and we subtract 23 minus 12, which gives us 11. So from there, we can continue on. 2 times 11 is 22, not 11 here, right? You're going to add a 9. So we add those together, and we end up with 31. So you're going to have to fight hard against your nature because most people, they just want to do the easy stuff. They see the adding, they immediately jump to that, even though that is probably the worst mistake you can make because it would change the result quite a bit. So make sure you follow PEMDAS to a T. So the final case type that I want to look at are ones that involve fractions and order of operations. So before you have a heart attack, it turns out these are not as bad as they look. You still follow order of operations, but the key thing to remember here is do not worry about that fraction bar. That's actually the last thing you should worry about. In fact, what you should really think about when you see these kinds of problems is a fraction is kind of like having the top part in parentheses and the bottom part in its own set of parentheses. They're separate from each other. So you should get the top as small as possible, then get the bottom as small as possible, and then the very last thing you do is worry about that fraction bar. You're going to see here that that is what we're going to do. We're going to go ahead and start off by following order of operations, doing our set of parentheses. So go ahead and do that. 9 minus 6 is obviously going to be 3. I'm not going to redraw the red parentheses again here. Just note that you could keep them as you go through the problem, but they're not really going to change a whole lot here. So after doing that, everything else is here. We're going to go ahead and move to the next step, which would be exponents. And so here we have a 3 raised to a third power. Again, remember, it's not 3 times 3. It's 3 times itself 3 times. So 3 times 3, which would be 9, times another 3 would give us a 27. There are no other exponent rules here, so we're going to go ahead and drop down everything else exactly where it was. So now this is where things get a little bit interesting because we're at the multiplication step, and you notice that we have it on the top and the bottom. So it turns out it actually doesn't matter whether you do the top or the bottom first because, again, remember, they are separate from each other until the very end. So I like to personally take the top and then work my way down. So we have 27 times 2, which will give us a 54. And then we have a negative 4 times a 5. So negative 4 times 5 is a negative 20. And then the 26 is just hanging out. So we're almost there. We'll go ahead and we'll subtract these two bottom numbers here. So 26 minus 20, that's going to give us a 6. So we're in our last step here. We have a fraction, and it turns out that you can simplify. 6 can go into both of these values, so we divide by 6, and that gives us an answer of 9 over 1, or you could just say 9. Because remember, anything over 1 is still itself. This is our last problem for the lesson. So in this case, again, I want you guys to try this on your own. Go ahead and pause the video now, and I'll resume in 10 seconds. Okay, so hopefully you were able to recognize that the first thing we need to do is handle this set of parentheses here. So we'll go ahead and do that. 9 minus the 4 gives us 5. Don't touch anything else. unless you're sure that it happens at the same time. So in this case, we are left with the following problem here. Now, from here, the next thing to do would be exponents. So that would be the 11 squared. Again, be careful. This is not 11 times 2. It's 11 times 11. So that's 121. So I don't recommend that you combine multiple steps in these problems, even if you're pretty confident, just because it's very easy to make a small mistake, which leads to a large mistake. So now we're at multiplying. So on the top part, we have negative 7 times 3. So that's going to give us a negative 21, leaving the 121 on the other side. And then we have the 20 times 5, which gives us a nice flat 100. And so from here, you can probably see where this is going. We subtract the top parts. We get 100 over 100, which is perfect because it can't get any easier than this. You simplify both, and that leaves you with 1. So when you're looking at the homework, make sure you pay attention to your exponent rules. I do want to remind you guys that there will be a quiz on Wednesday, so you can do that um, by next class. That would be great. You can do it at 5:45. I will grade those as soon as possible so you can get results back. But at this point, the quiz is going to cover 50-50. Half of it's going to be fraction related. The other half is going to be the order of operations related. And so keep in mind that this is technically material that the book considers review. This is material that you should know coming in, but I'm not going to make that assumption. I think that's a foolish assumption to expect that everyone remembers all of the rules that they learned back in school. And so this has been our review night. Okay, beginning next class, what we'll do is we'll start getting into what we consider the typical algebra. And again, if you have any questions, be sure to email me or post on our Canvas page, and I will get back to you as soon as I see it.